Good afternoon, everybody. So we are going to make the link between the offshore wind and the hydrogen business. We'll show you how we can unlock the full potential of the offshore energy. So my name is Stephane Lotode. I'm in charge of all the green energy, addressing hydrogen, biogas, and also cell solution. Okay, SOFRESID Engineering is a very old engineering company addressing engineering and also procurement services, construction. In the past years, we are really focusing on the energy business, providing project management, engineering, procurement, and also innovation. My colleague Gwenaelle Benoit will explain you how it's important today to be part of the innovation and to build partnership with clients, with scientists, and with all the local institutions. We are 350 employees, mainly engineer, technician. We are addressing four core business. Not surprised, we are placed all around the French coast, addressing the naval business. We are working for the naval owners, providing also solution, green solution with the cell. We are working in the industry, are mainly working for the global production site, production infrastructure, storage infrastructure, and distribution. We are addressing the wind. You have seen that our colleagues from SIPEM are building very big and very interesting project. We are performing the engineering with them. And we also specifically address the green business because we believe that the methods expecting from the new clients, either subsidiary of main companies or new startups, this business is expecting new methods, maybe faster, maybe helping them to build their model. So this is important to address that in particular. We are living a very enthusiastic period because now the energy we want to provide will be made in France, in Europe, built in France and Europe, and used in France and Europe. So it's very important for us to be part of all the local, national institutions, association. We have a lot of partnership with scientists also. So not surprised, we are very working with Brittany and Bretagne Pôle Naval. We are also working with Pays de la Loire and Neopolia and part of other local institutions. This is very important because we need to help our clients to build consortium, partnership for the innovation, and with the innovation start their new project. So we are working for the territories, and it's important also to help them to link with all the subsidiary that can come from the French government, European government, and a local government. We're already working on big project in France, Fécamp and Courseulles project. You have seen nice picture from SIPEM just before. We are also thinking of tomorrow with a modularized solution. This is a modularized solution of transition pieces, integrating all the electrical instrumentation equipment that we can be able to plug it directly in the foundation. We talk about doing that 50, 60 times for the same field. Now we will talk about what we can do for the hydrogen business and link it to the offshore business. So Gwenaelle.
Thank you, Stephane. Okay, a word maybe, because I don't know if everyone here is really familiar with the hydrogen market, with the focus of what is being done, especially in the North Sea, because clearly this is where you will have the more active parties, I would say, working on offshore hydrogen. What can be observed is that there are already some developments in Europe. It's a reality. We're not just talking about feasibility study or concepts. What can be observed is that you have some key players, I would say, especially in Netherlands, in Germany, Denmark, and in the UK, and with a clear upscaling of the developments that will occur around 2030. We can really see on the figures that you start from a pilot and that then you start having some commercial developments that will be occurring in less than 10 years now in the north of Europe. A word maybe about the value chain of hydrogen. How do you produce it and why do you produce it, basically? So clearly you need to start from its production. That can be through different vectors. So here we are mainly focusing on the renewable hydrogen that will be made from water electrolysis. So to do so, you will first obviously need to have a treatment of the water, especially if you are considering using seawater, for which you need to demineralize the water before you may use it in the electrolyzer. Some conversion also in terms of electricity, especially when you are working with a renewable that is intermittent. So that's something for which you definitely need to do some conversion and some balance plant, basically, and then only the electrolysis. I put a few other examples also of what can be done through the biomass or valorization of the natural gas, then with capture of CO2 in order to limit your impact on the environment, in which case the hydrogen is not considered as renewable or green, I would say, but more like what we call blue. Once you've produced your hydrogen, generally you don't leave it as it is. I mean, you probably need to store it, in which case you will have to compress it if you want to keep it as a gas. Or you can consider having different storage means, because the volume it represents is pretty massive, either through liquefaction or using some hydrogenation on a hydrogen carrier, or just converting it to other fuels, such as methanol or ammonia. Then you'll obviously need to distribute your hydrogen, either by direct transport, pipeline, or ship, if you want to export it. And when it comes to the use, you may convert it to another fuel, like I mentioned, or use it to convert it through fuel cells in order to feed, for instance, boats. I'll go maybe more in detail of what SOFRESID is doing with this mapping that shows the various solutions that have been developed. So I'll go more in detail through all of them, but basically what you can see is that from the electricity we may produce hydrogen either on a centralized solution, if you want to have only one single hub for the hydrogen production. You may elect to install it on your wind farm directly to have a decentralized solution. And then when it comes to the use, what you will do is either export it to the shore, or maybe consider having it as a fuel for local distribution, especially for maintenance vessels that will be operating in the area of the wind farms. When it comes to use, we also developed other concepts. The barge Elementa, that is a power conversion barge, so from hydrogen to electricity, and Seagull River, that is a refueling station distributing also the hydrogen. So all these all these concepts will be more detailed, starting from the production. Maybe, Stephane, if you want to have a word about what we are doing onshore?
It's important because when we talk about the perspective of the hydrogen, we could think that this will be for tomorrow. Will it be for the mobility? Will it be for the sustainable air fuel? We will see tomorrow. But what is sure is that today we need hydrogen. All the industry are needing hydrogen, either for the fertilizer, for the refinery, and also to produce e-fuel. So, who is leading the path? With the first production unit coming next year, is the industry. So there's two examples here of project that we are conducting engineering for. First is this unit producing 50 megawatts of hydrogen, decarbonized hydrogen, to produce and decarbonize the fertilizer. So we are just replacing the green hydrogen, the gray hydrogen, with green hydrogen. So for that, we are conducting standard engineering, developing pre-FEED, CapEx evaluation, and we can hope that this project will start the first construction next year. The second example is that this very smart power plant proposed by Hydrogène de France, HDF. They have a smart solution of power plant. The solar plant, the solar farm is connected to the grid, providing power in the day, but also dedicating a part of this production to produce hydrogen during the day, storing it in a quite large storage area, and giving back to the grid during the night with fuel cell and also an additional battery storage. So this is for tomorrow, next year. They already start a plant, a well-known plant in Guyana. So you can see we are talking about 50 megawatts. Today we are already starting to offer and work for production of 100 megawatts. And we all know that tomorrow the need for the e-methanol and sustainable air fuel will require maybe 100, 200, 500 megawatts. There's already some plants like that worldwide. So we hope that there will be, maybe in 2-3 years, some mega factory of methanol in France. So for that, we are conducting the FEED studies and procurement activities.
Thank you, Stephane. A word about the roadmap that we've defined with respect to hydrogen production developments. So like I've mentioned before, what we've observed clearly is that there is clearly a key target to be able to propose commercial solutions by 2030 if we want to keep up with the pace that is already being paved in the North Sea. And what we've considered is that if we want to be ready to do so, we need to both on parallel on two approaches. The first one being to have some pilots to qualify the solutions to make sure that they work and that they work in an offshore environment. And the second one being really to prepare for these commercial applications by conducting concept evaluation and also feasibility studies. And we truly believe that it is very important to link them both so that we can have some lessons learned from the demonstrator to be integrated also in the design that will be conducted by 2029 if we want to have a deployment by 2030, 2031. But also to start conducting the feasibility studies and so on for the large scale, even now, if we really want to be ready in time, I would say. So having this in mind, we focus, I would say, our development on these two key points. First, having demonstrator or maybe smaller projects to start the business, I would say, of the offshore hydrogen. And secondly, starting considering concepts that would allow having massive upscaling and projects that are above 100 megawatts for the hydrogen production. So one of the first development that we've done, the most recent one actually, was an integration of the hydrogen production capacity on the floater. So in that case, it was a Star One. Okay, since it is the one that is developed by Saipem, I would say it was a starting point. It was the most straightforward for us because we knew exactly what the structure was like, what was the space we had. And what we've done here is that we've integrated all the hydrogen equipment on one of the external column that was empty. So we had some space, and here I got an animation that explained a bit more in details how it was made. So basically what you will have is 3 floors. The first one being really dedicated to pumping and treating the seawater. The second one dedicated to electrical conversion. And the last one being really meant for all the process with a 5 megawatt electrolysis capacity through PEM. What we've done as well is include some storage facilities. We've considered 1 ton in the present case, with the idea of being able to discharge the hydrogen through a buoy to vessels that then could work with fuel cells. And yeah, like I've mentioned before, first application being really for CTV and SOVs that are ensuring maintenance and inspection on the wind farm. So that we remain on the field, clearly. What we've developed is to have something that is meant to be used directly there. On mid-scale development, we've considered also centralized approach in order to be able to have more maybe production capacity on a single structure. With either new or repurposed facilities, because we could definitely use some previous oil and gas facilities that are already existing, especially in the North Sea. And with some marinization and integration of equipment, either on a fixed platform or on a floating barge or vessel. Stephane, maybe if you want to have a word about Sea Life project.
It's a very nice project that we developed with a lot of partners, mainly led by Life and funded by Pays de la Loire. So we explore, in that picture you can see only a solution of 10 megawatt, floating megawatt solution, but we explore a lot of other solutions and also the possibility to recover existing assets of the offshore oil business, mainly for the North Sea. So a very nice project, and we need to do that always in partnership.
And one of the final conclusion also was to prepare for a demonstrator with a 10 megawatt capacity on a barge. Now, like I said, we are also thinking about the future and about how massive could be the production in the future and how we could adapt to that. So we have in SOFRESID a strong naval and stability expertise, I would say, deriving mainly from the oil and gas. And we decided to use this expertise also to design and to consider different type of floating structures or fixed platforms, and to see based on the size of equipment and on the storage capacities that could be needed on this project, what would be the best floating solutions. So obviously, depending on the sea state, you will have different conclusions. But basically, yeah, we've worked on concept more in detail, but semi-sub that could go up to 500 megawatts, and FPU, where we do not have here a storage capacity because we've considered some export that was directly from the sea to the shore through a pipeline. A bit more details maybe about this last concept. So we've called it high batross. So it's obviously co-located with wind farms. And what we've done is that we have 5 modules of 100 megawatt each. So it's a solution that could be adapted also to a lower production capacity. If you want to go down to 100, 200, you just need to put fewer of this production module. And you have also a small storage capacity here for local distribution afterwards, but most really of the production is meant to be exported to the shore. In the present case, we considered also a compression for the export that was up to 80 bars, so that it could be adapted to the gas network, I would say, inland. So this concept is something that we've developed, I would say, internally. But in the future, we'll collaborate with a partner, EMEC, in Scotland, to do a feasibility study together and to see how it could be adapted in the North Sea context.
Yeah, it's just a word. It seems to be very futuristic. It's a concept, an exercise. But if you look better at the possibility of that, it could be offshore, but it could be also built in a remote area and then installed in an harbor. So you can put it on the harbor and get the power from the field. So you can put it where you want. And already you can see that some development of that are appearing in Germany, probably in Poland too. So our friends of North Sea are already thinking about that and will propose a solution in the coming years.
Thank you for the clarifications. Now, going further in the distribution chain, we got a few concepts. Okay, so here I gathered them to go a bit more quickly, maybe, about a refueling station. So it's a platform that has some hydrogen production capacity, storage, and then that can distribute the hydrogen as a bunkering station, basically. So this is a concept that we've called Seagull. It has a kind of a sister, I would say, that is a barge for more sheltered environment. We've got capacities also in designing export pipeline for hydrogen. And when it comes to export, there are also some developments about hydrogen carrier vessel. And with that respect, we are working with the region of Bretagne to develop a concept and to see what could be the technico-economicals behind such an export means. To support us, I would say, in this development and also to work a lot on the storage and on the transport capacities. We have a partnership with a laboratory called EasyLab that has developed a liquid inorganic hydrogen carrier called Hydrosil, and for which we are supporting them in the engineering, I would say, of the upscaling of their solution, and about the marinization also of their means. I don't know, Stephane, if you want to detail maybe a bit more about the
It's just a word
marine
that
mobility.
the possibility of the hydrogen for the naval business. We are already working for service boats, passenger boats, because a lot of local area want their hydrogen ship, but we are also working for crew technical vessel that will help offshore wind field to be greener, and it's possible. It's possible. The power is there. The hydrogen is maybe not yet there, but the solution is viable.
I think we need to speak maybe a bit faster because I can see the time is running. A word about Elementa. So it's a power barge that is really meant as a first application to do cold ironing. That is to say, we produce electricity so that the vessels that are quay can cut their auxiliary engines that are mainly diesel at the moment and use electricity. So it's a support, I would say, for harbors that do not necessarily have a strong connection to the grid, who do not have the fixed infrastructure to do such an electrification. So it's more of a support solution, like a transition solution maybe, or to answer also to peaks where you have a grid that might not need to deliver strong energy for a very long time. Could be applied also to deliver electricity to yard if they are equipped with electrical.
Yeah, the purpose is quite simple. It's just an hydrogen power barge providing power in a remote area. But when we talk about remote area, there's a lot of remote area also in the main port in the world where you don't have electrical power at the berth when you are. So this is providing this power. It's just a 2 megawatt power for the time being. The importance of working in consortium. So we are working with Hydrogène de France and Ruby Terminal, and we have been granted support from ADEME, Corimer, and Polmer Bretagne Atlantique. So this project is aimed to start in the coming months for an application for the Ruby Terminal in Rouen. So we are ready to start that in the coming months.
Okay. Small animation also about the barge to see basically what are the devices you have in there. A few comments maybe? Yeah.
Okay, well, the shape of the barge is probably not the final one. So this was the first shape for river purpose. So we can also think about a simple pontoon for yard application. The gain of the barge is that you don't need to store the hydrogen on the berth with all the required permitting that you need. So all the hydrogen storage is on the barge. Then, of course, you got the fuel cell and the power management system. It's quite simple, but when you talk about something simple, it should be cheap, because at the end, the operator of that barge is selling the green electricity.
And now finally, because all these topics clearly are connected also to how we could guide a territory and a maritime territory, I would say, in order to decrease the carbon footprint in general. So I extended a bit the perspective by talking not only about renewable hydrogen, but also about all the services that can be made in order to decrease the carbon footprint of a harbor. At the moment in France, we have some ZBAC developments that have been announced. The two first being in Dunkirk with decarbonation, and the second in Sirius in Fos-sur-Mer. Other cities now are being candidates also to have such development, with really the development of what is called an industrial ecology. That is really meant to valorize as much as possible the waste energy, the byproducts, and so on, and to create a whole ecosystem where basically everything is reused, and you have no loss, or at least as little loss as possible, I would say. And to do so, we have also some developments about carbon capture, segregation, transportation, and sequestration and uses, especially about conversion into e-fuels.
ZBAC in France are very amazing tools that we are giving to all the developers. So all the developers can propose their biogas, hydrogen, e-fuel project. So rush to that. We are engineering. We are here to help the developers to upscale, de-risk their project, and propose their candidature to the ZBAC project. It's very important for France.
In the present case, we've been writing on the candidature of Lac, that is a city very close to Pau, where we have an office, and we've been working with them on their submission with the project Lac is back. Thank you very much for your attention. I don't know if you want to have a word of conclusion, maybe, Stephane?
Thank you, Gwenaelle. So we are engineering. We are here to help you to connect the wind and the hydrogen business, and it's for tomorrow.
Thank you.